Hi, y'all. Welcome to 4.4. This will be part 1 of this lesson. We are looking in this section at solving log and exponential equations. And there's two things that can happen. We can solve them by hand, or we may need to solve them in the calculator. And it just depends on the setup, okay? What we want to do first is simplify as far as possible, convert between log and exponent form as needed, as in drop and cross, convert both sides to the same base if needed, and then convert the log and exponent base to the same value. All of those can be solved by hand unless the bases cannot be converted to equal values, or if the problem has too many different log bases. Okay, so here are a few examples. So if we look at A, 5 to the power of x equals 9, we know that 5 to the first is 5, and 5 to the second is 25. So we know our answer is going to be between 1 and 2. But we can't convert a base of 5 and a base of 9 into the same value. So this is when we go to solve in the calculator. Okay, to solve this in the TI graphing calculators, y1 is 5 to the power of x, y2 is 9. Okay, go to graph, then do second trace, select 5 for intersect, and then hit enter 3 times. And that will give you the intersection. Okay. To do this on Desmos, which I'll demonstrate here, the first line is y equals 5 to the power of x. The second line, type y equals 9. Okay, and then hover over the intersection, or click. This will actually click, that will make more sense. Click the intersection point. And it will give you the x value that you need. Okay, so let me demonstrate that for you. Sorry, I didn't already have this open. All right, on line 1, y equals 5 to the power of x. And on line 2, y equals 9. Okay, and you can touch and zoom and wiggle this. When you click on that intersection point or touch it, it will give you the coordinates, 1.365, comma 9. So that solution is x equals 1.365. And there's your solution. So let's look at B. We want to try to simplify this before we jump straight to the calculator because we want an exact answer more often than not. So we can convert this to log form, drop and cross. When we drop a base e, it's a natural log. Natural log of 7 would be equal to 3x. That got the x out of the exponent. And now all we need to do here is divide off the 3. And x equals natural log of 7 all divided by 3. This is an exact answer. This is your exact answer. Then when we round this, type this in a calculator, natural log of 7 divided by 3. On Desmos, your natural log is under the functions over here on the side, and then you have to go down a little ways to the ones that say calculus. It's okay that it says calculus. Natural log of 7, close that parentheses, and then divide by 3. Round that to 3 decimal places, 0.648 with a 6 after it, rounds the 8 up to a 9, so 0.649. It's approximately equal to 0.649, and that is your approximate. So you can drop and cross and isolate that log, isolate the x. That'll work very, very smoothly. So let's look at a few more examples. Let's look at C. We have natural log of x equals -1/2. Hey, this one's really straightforward to solve. Drop and cross. E, drop the base. Natural log is log base e. E to the -1/2 is equal to x. So all we need to do is put e to the -1/2 in the calculator. E, I don't think is on the functions. I think we have to go to the calculator, go to the keyboard for E. I'm going to check just in case. Where'd those go? Yeah. So to get E, go to the ABC keyboard and type the letter E. Okay, you'll see on the in the line that it gave you that 2.718 number. Okay, so it knows what E represents. Then go back to your math keyboard to the power of, and that's going to be a -1/2. Make sure that 1/2 and -1/2 stays in the exponent. If it doesn't, use parentheses as needed and hit enter. On the TI calculator, the E and natural log buttons are in the far left-hand column near the 4 button. You have the natural log button, and then second of natural log is E to the power of X. So you have those buttons on the handheld calculator as well. So 0.607, because that 5 rounds it up. X is 0.607. E to the -1/2 is an exact. 0.607 is the approximate. So let's look at D. We have natural log of x equaling natural log of 4 plus natural log of 6. Condense this log first, as in write it as a single log. So natural log of x will stay. We have 2 separate logs being added. When we condense those, they multiply. So natural log of x is equal to natural log of multiply 4 times 6. That's 24. And then that x has to equal 24. And this is your answer. It's both exact and approximate. There really isn't an approximate here because your exact answer is 24. So let's look at E. Looks like there's a lot going on in this problem, and there kind of is. It's going to be okay, I promise. What we want to do first is isolate E to the power, as in get it by itself. Isolate E to a power first, then work with it. So we're basically treating this like 2a minus 2 equals 4 right now, and we're solving for a. So we'd add the 2. So 2e to the x over 3 equals 6. We added the 2. And then we need to divide off this 2. This 2 is multiplying by the e. So e to the power of x over 3 equals 3. Now, we can drop and cross to get the exponent variable out of the exponent. Okay, drop a base e. It's a natural log of, go to the other side, 3 equal to x over 3. That gets the x where we out of an exponent. X divided by 3. We solve by multiplying both sides by 3. So x is equal to 3 times natural log of 3. That would be an exact answer. And 3 times natural log of 3. 3 times functions natural log of 3, close that parentheses, enter. And that is 3.296, rounded to 3 decimal places. 3.296. Okay, again, we have our exact answer, and we have an approximate. So look at F. We have a bunch going on in problem F, okay? We've got logs on both sides, and we've got some other terms there as well. So we are going to condense these two logs. So we will have log of x equal to log of, these terms are being subtracted. So when we condense that into a single log, they condense by dividing, and that plus 1 is still on the outside. So this is log of x equal to log of 4 plus 1. Okay? These bases are the same, but this plus 1 on the outside, this plus 1 on the outside means dropping and crossing is not going to work very well at all. So what we're going to do here is go to the calculator, and either Y1 or line 1 will be this left side, and either Y2 or line 2 will be the right side. So you can do this in the calculator, or you can do this on Desmos. So if we go to functions and go down to that calculus group, we get log. Log of x, put a y equals in front of that. Y equals log of x. And then the next line, y equals, find that log again. That would be log of 4 plus 1. And there's our equation. So if you look where, I'm going to come back up here and turn off these first two. And so now I'm looking at just these two. If we look, that intersection is out here. If you'll tap near it, it will go to it. And that intersection there is 40. All right, looking at G, we have 5 to 1 power equaling 7 to a power. These bases will not convert. We cannot convert to the same base. Both of those numbers are prime. So when we cannot convert these to the same base, go straight to the calculator. Okay, do Y1 and Y2, or line 1, line 2. So I'm going to erase the ones I had up here before because they're already on. Yeah, I know that's an error. So y equals 5 to the power of x minus 1. Okay, now this is a quirk of Desmos. It put the minus 1 outside of the exponent. I need it in the exponent. So here's what we need to do. Use a parentheses and then put the x minus 1 in the parentheses to keep it in the exponent. Okay, on y2, we'll have to do the same thing. 7 to the power of, open a parentheses, and x minus 2 is what we want here. And now when we find the graph of these two, and we look at, where is that? And we look at where they intersect. Okay, they're getting closer and closer and closer. They're getting closer. It is going to be way up here. I'm going to zoom in. About to give up on this over here. If you will touch on Desmos, it will show you where that solution is when you get close enough to it. I didn't think it was that high. It is. Nope. All right, I missed this somewhere, but that solution is 6.783. Using the calculator there to solve that. Okay. Going to H, there's a lot involved in H, and we want to do similarly to what we did a couple problems ago, in that we want to isolate first where the exponent is. So we want to isolate, get by itself, the 7 to the power of first. Okay, and once we isolate that, then we can solve. So again, we're treating this like it's 4a minus 10 equal to 6. So we'd add the 10 over. So 4 times 7 to the 2x minus 1 is equal to 16. Then divide off the 4. And 7 to the 2x minus 1 is equal to 4. Okay, and here we want to drop and cross in order to solve this. We only have one variable, so we can drop and cross this. It's going to be log base 7 of 4 is equal to 2x minus 1. And now we want to isolate that x, so we'll add 1 on both sides. Log base 7 of 4, then add 1. We cannot add the 1 inside the log. That's equal to 2x. Then we will divide both sides by 2. We'll divide both sides by 2, and we'll have an exact answer. Scoot things up a little bit so I have a little more room. Yep. This will give us an exact answer. Log base 7 of 4 plus 1 outside of the log over 2. That is an exact answer. And then to put this into the calculator, turn those graphs off, go to functions again and go down to that calculus group, and the button that's highlighted here that says log and has a base of A is what we need, because it gives you a space over here to put the 7 in for the base. So log base 7 of 4, close the parentheses, add 1, and then we want to divide all of that by 2, and that's not going to divide all of it. So I'll put the entire numerator in parentheses. Then it will divide everything by 2. So 0.856. X is 0.856. All right, there is part 1 of 4.4. The second part coming soon. Bye, y'all.